Dear friends, welcome to ESE online platform, ESE Engineering Academy. Important concepts and important questions on irrigation engineering for GATE and ESE prelims. In the previous session, I explained how to prepare irrigation engineering. As the subject is vast, lots of amounts of theory is available in the subject. It's not easy to gain command over the entire subject. Objective-oriented learning will give better result. In what areas generally questions are framed? What areas you must essentially go through? We will discuss one by one chapter. In the first chapter, basics of water resources engineering. In this, generally we learn about methods of irrigation. He will give the conditions. He will ask you what type of irrigation, what method of irrigation do you adopt. When do you go for border strip method? When do you go for sprinkler irrigation? We know pretty well. When the water scarcity is high, when the ground is having steeper slope, when the soil has got less porosity and higher permeability. As a result of, by ordinary methods, if we supply water, it cannot be stored in the soil, so ordinary methods cannot be useful for the crop growth. So they will ask, in which of the following situations sprinkler irrigation is preferred? To irrigate paddy, most common method adopted in India is dash. Which of the following is an example of contour farming? Contour farming is hilly irrigation. Coffee, tea, ilachi, corundum, etc. Such questions, based on methods of irrigation, either he will give the method of irrigation, he will ask in what situations, or he will give the situation what method is suitable. In this particular chapter, the three mathematical formulas are important. Two are there in border strip. In border strip irrigation, we have a piece of land supplying water at the rate of Q, area A, storage depth externally is Y, rate of infiltration is F. In terms of these four parameters, how do you calculate the time required? I have given this formula already. Time required is equal Y by F log Q upon Q minus FA. To develop this formula, we use continuity equation. Volume of water supplied is equal to volume of water infiltrated plus volume of water stored. If you nullify the amount of water stored externally, the formula for Amax, rate of supply of water by rate of infiltration. Friends, if you are GATE aspirant, a problem on this is expected. If you are ESE prelims, either this formula or this formula, both are applicable. Both are useful for ESE prelims. For ESE mains, they will ask derivation for this. You have to practice the derivation also. Derive an expression to get the time required to irrigate a piece of land by border strip irrigation with usual conventional symbols. Such questions may be asked. All these are pertaining to the border strip irrigation. Then if you see, the next method of irrigation is sprinkler irrigation. In sprinkler irrigation, if you have the sprinkles placed, spacing in y direction is Sy, spacing in x direction is Sx. With what velocity water will be ejecting, then amount of water released, rate of supply of water by each nozzle, Sx into Sy into V, total amount of rate of flow delivered to the field. If N is the total number of sprinklers, N into Q, N into Sx into Sy into V. This formula is suitable to be given for both gate and ESE. Remember the symbols. Sx is the spacing in x direction between two rows of sprinkles, nozzles. Sy is the spacing in y direction. V is the velocity of the water ejecting from each nozzle, meter into meter into meter per second. You will get the Q value in meter cube per second into number of nozzles. You will get the total water delivered to the field by sprinkler irrigation. You will get the formula. If he wants to give a question, either they will give a theory question or otherwise numericals dena chahe to they will give on border strip irrigation or otherwise sprinkler irrigation. Generally, in the first chapter, no questions are being asked in the examination, whether it is a gate or ESE. On and off only. ESE sometimes is given, gate very rarely the questions are given in this. If you are gate aspirant, you can just neglect this chapter only to minimize your effort and time. To save the time, to minimize the effort. If you have the time, don't forget to read that also. Don't take my advice in the wrong way. Please understand this. Let us go to the next chapter we are having. The second chapter we are having is soil, water, and plant. Actually, it is the introduction for the third chapter, water requirement of crops. I am referring to the chapter numbers as per your material, water requirement of crops. These two chapters. Second chapter is an introduction chapter for chapter 3. For gate, must and should question is coming from chapter 3. 90% of the times, gate papers will have the question on water requirement of crops. Some fundamental definitions are given in the chapter of soil, water and plant. All those basic concepts are needed to understand the subtopics here. What are the important subtopics we will see one by one. In this particular chapter, importance of 6 moisture contents you must read. There are definitions also. Saturation capacity, field capacity, optimum moisture content, temporary wilting point, permanent wilting point, ultimate wilting point. What is available moisture? What is readily available moisture? What is the relation, general relation between readily available moisture and available moisture? depth of the water required to be available in the soil at a particular moisture content. I repeat, depth of the water that must be present in the soil at a particular moisture content MC is given by, there is a SD into MC. As whenever the farmer is supplying from the abundantly available canal water, farmer is every time raising its moisture content of the soil from OMC to FC. Depth of each watering is YFC minus YOMC. So I hope you are able to recall dW is equal to SD into FC minus OMC. What is the depth of the water every time farmer is supplying when he is watering to the field? What is the frequency of irrigation? The time interval between two consecutive waterings. Frequency of irrigation is one important concept generally asked in the examination. He will give the moisture contents percentages. He will give the root zone depth of the soil D. He will give the specific gravity of the soil. Sometimes specific gravity may not be given. Specific gravity is nothing but porosity by field capacity, or a dry unit weight of the soil by unit weight of water. Any one of these two formulas we can remember. S stands for specific gravity. It's the porosity by field capacity, or dry unit weight of the soil by unit weight of water. Kilonewton per meter cube by kilonewton per meter cube. Frequency of irrigation, as I told you, time gap between two consecutive waterings. This area is very important for both gate and ESE. For gate, 90% important. For ESE, 50-60% important. Frequency of irrigation is given by dW by Cu. If I supply water once, I will supply for a depth of dW. Every day plant will consume, plant will demand water with a depth of Cu. Cu is called daily water demand of the crop. As I told you, Cu depends on 6 or 7 factors: temperature, evaporation, transpiration, evapotranspiration, sharing of water, water required for metabolic action, water required for growth of the crop, water required for sharing of the water between the surrounding soil particles. Temperature and atmospheric pressure will play an important role. Humidity also will play a vital role in the calculation of Cu. Remember, one of the most important formula, as we are dealing with important concepts applicable for GATE and ESE, for both the exams it is equally important. Frequency of irrigation is equal dW by Cu. Depth of each watering divided by consumptive use of the crop. Millimeter by millimeter per day. Frequency of irrigation will be available in days. Please remember this. Base period, crop period you should know. Wet crops you must know. Simple theory questions may be asked, especially in ESE examination. Rabi crops, Kharif crops, and summer crops. Summer crops also known as jade crops. Importance of these three crops: 4 months, 4 months, 2 months. Generally for 10 months all three crop seasons are over. Remaining 2 months land will be idle. At this moment we should know what is meant by leaching operation. When there is a salt accumulation during the growth of the crop, flooding the land with water and removing the salt It's one of the land reclamation process. Soil reclamation or land reclamation process is leaching. Definition may be asked. Leaching can be defined as the process of land reclamation. In this step 1, flood the land with water, retain the water for 1 day, release the salt water after 1 day. The land is free from excess salts. Because salts are getting accumulated because of various reasons, that salt must be removed before we go for the next crop. Leaching process, even though leaching water is negligible, leaching process is very important to be taken at the end after harvesting of every crop. रबी सीजन रबी क्रॉप का हार्वेस्टिंग होने के बाद एक बार, खरीफ क्रॉप का हार्वेस्टिंग होने के बाद एक बार, yearly 2 times leaching operation must be carried out. You must know what is meant by delta. Delta water is consumed in B days. DW water is consumed in F days. CU water is consumed in 1 day. So if you observe this relationship, delta by B is nothing but daily rate of water consumption. DW by F is also daily rate of water consumption. It is equal to CU. In solving the numerical problems, one of the wonderful formula that will be highly useful. Delta by B is equal dW by F is equal CU. This area question may be asked. Then the relation between the definition of duty is also important. Area divided by discharge. Area means culturable, cultivated command area. Culturable, cultivated command area by discharge will give duty of water. Duty at various locations, names are important. Duty at the head of the main canal, grass quantity. Duty at the head of the water course is called outlet discharge factor or simply outlet factor. Such names are important terminology. What is core watering? What is paleo watering? They are important, friends. When delta is in meters, numerical problems may be asked. When delta is in meters, when delta is in centimeters, (864) B by D. When delta is in centimeters and delta is 1.98 B by D with appropriate units, when delta will be in the units of feet. In this area, generally one question is asked. In the next one, if you see in the same water requirement of crops, 5 types of efficiencies are generally asked. You must be aware of all these efficiencies. Water application efficiency, Q plant by Q field, like that. I'm just giving as an example. The difference of Q plant and Q field and Q plant will give the application losses in the field. Water use efficiency, plant के लिए required water, leaching के लिए required water divided by Q field. As Q leaching is negligible, eta A is almost equal to eta U. Water application efficiency, water use efficiency, both are same. Then you must know what is water conveyance efficiency, Q field by Q canal or Q source. What is the overall efficiency called water irrigation efficiency? Q plant by Q canal, which conveyance efficiency. Water conveyance efficiency multiply with water application efficiency. In 2-3 examinations, they asked about water distribution efficiency also. 1 minus Q mean you express in percentages. It is also 2-3 times it is asked in the examination. Give concentration to application efficiency and conveyance efficiency. In this area, also more than 5-6 times the questions have been framed. One more important area in this chapter is, obviously this is the most important chapter of all 12 chapters. Irrigation requirements. Sorry. In irrigation requirements, consumptive irrigation requirement, as you know, consumptive use minus effective rainfall, net irrigation requirement, consumptive use minus effective rainfall plus daily leaching, FIR value, CIR by eta A, NIR by eta U, and GIR. Gross irrigation requirement is equal CIR by eta A into eta C, NIR by eta U into eta C, FIR by eta C. These areas are very important. They may give in terms of losses, for example, canal losses 20%, so conveyance efficiency 0.8, field losses 12%, so sorry, water application efficiency 0.88. Such questions may be asked, should not get perplexed, should be in a position to get the concept immediately. This is the area generally questions are asked. In the second chapter, duty, delta and base flood relationship is important. 5 types of efficiencies and 4 types of irrigation requirements. These are the most important areas where the questions can be framed. For example, if you take a single problem, in a given field, irrigation requirement is 24 centimeters, field loss 10%, canal loss 20%. Gross irrigation requirement is dash. Because it is given NIR leaching water के बारे में कुछ भी नहीं दिया, NIR must be taken equal to CIR. The question may be given in GATE, the question may be given in ESE prelims examination also. ESE prelims, 50% or 40% theory, 60% problems. In GATE, most of them are problems only. Generally, they will ask, or if they give 3 questions, 1 question theory, 2 questions problems. Generally, paper setters will do like that. As an example, I am telling gross irrigation requirement is equal to consumptive irrigation requirement by eta A into eta C. Consumptive irrigation requirement is 24 centimeters. Field loss 10%, therefore field loss 10% means eta A is 0.9. Canal loss 20% means 0.8. It is 20% means 80% efficiency. 24 by 0.8 is 30. 30 by 0.9, that is 33.33 centimeters. What is the gross irrigation requirement? Within 20-30 seconds, you can complete the problem. Such numericals only will be asked in GATE and ESE. I repeat, combinedly in second and third chapters, duty, delta and base bed relationship is important. They will ask for rice crop, whatever discharge is supplied, same discharge is supplied for wheat crop also. Water requirements are different, duty is delta is different, base spread is different. For rice, delta is around 130 to 140. For wheat, it is 35 to 40. Rice comes to maturity within 140 days. Wheat comes to maturity within 120 days. If 2,000 hectares is irrigated in rice crop, how much land can be irrigated with wheat crop? Much more than that, around 6,000 to 8,000. Such type of, because he said same waters are used, discharge is same for both. Mathematical concepts are important. Generally developed relations with mathematical application, you must be thorough. Problem standard will not be high. To what extent you are able to understand the subject is important. I told you subject is vast. Remember, practice only known, verified, standard models only. Don't go on reading the theory part. Don't waste your valuable time and energy in this precious moment. Just only 5 weeks. Second chapter and third chapter, this is the one. If you see the fourth chapter, quality of irrigation water. Quality of irrigation water. Which soils are more dangerous? Saline soils and sodic soils. Which one will be causing the salinity and sodic nature? How do you reclaim those soils? Only leaching is sufficient, or first add gypsum then followed by leaching? Such concepts, theory questions may be asked. How do you test the quality of irrigation water? By 3 parameters. One is the concentration of the impurities, dissolved salts, excess sodium, and dangerous elements like boron, selenium, etc. 90% of the time they are asking the questions on sodium absorption ratio. Sodium, the most important, the most validating test parameter. Sodium absorption ratio will give, formula is given by sodium ion concentration by square root of calcium ion concentration plus magnesium ion concentration by 2. Remember, all 3 ions concentrations must be taken in milli equivalent per liter. From ppm, if you divide with the respective equivalent weights, you will get in milli equivalent per liter. mg per liter by equivalent weight will get milli equivalent per liter. Don't take this formula in ppm units. Be cautious. Please do remember milli equivalent per liter. If SAR value, as you know pretty well, other parameters are there. If you have the time, you can go through, but I am telling because it's the most important. 0 to 10, S1 water, low sodium water. 10 to 18, S2 water, moderate sodium water. 18 to 26, S3 water, high sodium water. More than 26, S4 water. First two are acceptable. Second, third are not acceptable. Excess sodium is dangerous for the crop growth. ESP, RSC, such parameters may not be asked. Boron should not exceed 2 ppm. Selenium should be always 0. These points you must remember regarding quality of irrigation water. I repeat, important for ESE, not at all important for GATE. GATE aspirants need not study this chapter. ESE aspirants must and should read this chapter. Please. Let us move on to chapter number 5. Design of lined canals. To minimize the losses, lining is done. What type of materials are used for lining? What type of lining material will have how much lifespan? Should have general idea and general study about those methods of lining, materials used for lining and their lifespans. For example, cement concrete 40 to 45 years, brick masonry 35 years, lime mortar 30 years. Like that, every lining material will have its own lifespan. When you make a lining, the bottom corners are rounded to avoid the accumulation of silt, to keep the total area, entire area available with water, not to see that the silt will be accumulated at any given cross section. Silt will be always in the moving state, in the state of suspension. We see that the bottom corners are provided with curvature. When the design discharge is less than or equal to 100, triangular lined canal with rounded corners. Rounded corners is the common phenomena for lined canals. Triangular cross-section lined canal. The two formulas worth remembering. Y is the depth of the flow. Theta is the angle the free surface makes with the side slope. Wetted perimeter 2y into theta plus cot theta. In case of triangular channel, R is equal to A by P, that is equal to Y by 2. Hydraulic mean depth will be half of the depth of the flow. One important relationship on which previously in ESE, in other competitive exams also questions are asked. In GATE, so far, only once about freeboard it is asked. So far, lined canals is untouched, almost untouched in GATE paper. I repeat, GATE aspirants, chapter number 5, you can just have a glance, remember the formula, forget. Forget means skip off to the next chapter. And if it is the design, when the discharge is more than 100, trapezoidal lined canal with rounded corners, trapezoidal lined canal, just rectangular area is extra, by is the extra factor, by plus y square into theta plus cot theta, and wetted perimeter is equal to b plus 2y into theta plus cot theta. how to develop, we have seen, but if he gives the problem, he will give only on triangular lined canal, only in ESE mains. There is a chance for a problem to appear only in ESE mains on trapezoidal lined canal design. Remember, whether it's a triangular lined canal or trapezoidal lined canal, bottom corners are rounded. The bottom corners are rounded to avoid accumulation of silt, to keep the entire contact area to be filled with water. Very important. How much freeboard will be provided? Sometimes if you are writing state level examination, freeboard less than 10 cubic 0.6, more than 10 cubic 0.75, like that meters. And this is a very simple chapter, small chapter, useful for ESE, not at all useful for GATE. Let us move on to chapter number 6. Design of unlined canals in alluvial soils. Design of unlined canals in alluvial soils is one most important, second most important chapter next to water requirement of crops. I told you, 3rd, 6th and 9th chapters are important. If time permits, go through 8th chapter, diversion headworks also. If he gives diversion headwork, he may give the problem on exit gradient. We'll discuss. First, let us see design of unlined canals in alluvial soils. What are the chances of silting? How can we have the covering of the cross section? What are the theories available? The 3 theories available. Most important, Kennedy's critical velocity theory, and still more important, Lacey's regime theory. The single formula given by Kennedy, V0 is equal to 0.55 md power 0.64, Kennedy's theory. For Lacey's theory, based on 3 important basic equations, AF square is equal to 140 V power 5, V is equal to root of 2 by 5 FR, V is equal to 10.8 R power 2 by 3 S naught to the power of 1 by 3. The 3 fundamental equations given by Lacey's design theory, Kennedy's critical velocity equation, and if you are writing a state level examination, what are the drawbacks of Kennedy's theory? What is the drawback of Lacey's theory? What is the common drawback in both? Such theory questions may be framed, but if at all they give the question in this chapter, they will give on Lacey's theory. Apart from this, these 3 are empirical without any scientific proof, and 5 more formulas with proof. They are also very, very important. I need not say those formulas. P is equal to 4.75 times root Q. V is equal to QF square by 140 whole power 1 by 6. F is equal to 1.76 square root of D bar. Mean diameter is in millimeters. S naught is equal to F to the power of 5 by 3 by 3340 Q power 1 by 6. Still other formulas are there. Lacey's regime's cover depth is also one important formula. 1.35 times Q square by F whole power 1 by 3. All these relationships. Apart from this, what are the 5 types of regime conditions also you must practice and remember: initial regime, final regime, true regime, apparent regime and permanent regime. About these 5 regime conditions also you must be in a position to identify and distinguish. In this particular chapter, this was the summary for chapter number 6. Chapter number 7 we are having canal regulations. In canal regulation works, even though there are 7-8 types, most important is cross drainage works is very, very important. Numerical problems also may be asked. When do you get aqueducts? When do you get siphon aqueducts? These two are branded as type 1. In which of the following situations superpassage is proposed? In which of the following situations the superpassage will be subjected to siphonic action and called canal siphon? Type 1, without siphonic action with siphonic action. Type 2, without siphonic action with siphonic action. If you are given the numerical data, you have to observe whether it's a type 1 or type 2. Then you have to see whichever is traveling on the ground, its maximum flood level on of the water traveling on the ground greater than or less than bed level of the water traveling at higher elevation. If the maximum flood level of the water traveling on the ground is greater than the bed level of the water flowing at higher elevation, siphonic action. Because that much depth has to get compressed. When the streamlines get compressed, converging streamlines will result in increase in area. Increase in area will result in decreasing in pressure. From the status of atmospheric pressure, it will come down to a pressure less than atmospheric, nothing but siphonic action. So greater than siphonic action, type 1 greater than siphon aqueduct, type 2 greater than canal siphon. Given the numerical data of canal and drain, what is the discharge, what is the bed level, what is the depth? Most commonly, for both ESE and gate, such an area is the common area. He will give the complete description, what type of CD work is proposed. Canal runs over the drain with the canal discharge 20 and drain discharge 200. Maximum flood level of the drain is plus 200. Bed level of the canal is plus 196. Obviously, siphon aqueduct is the answer. Fraction of second, you can keep the answer. And to some extent, one more topic in this is canal modules also a little bit important. Not as much important as cross drainage works. When do you say subproportional module, proportional module, super proportional module, hyper proportional module? About these 4 types of modules, you must have an idea. Apart from this, what is flexibility? dq by q divided by d capital Q by q. Most of the people will not refer to this. Be in touch with such formulas. Sometimes, if such questions are given, definitely you have an edge over the others where there's more areas are untouched by the people in this level. You can get through, you can get an advantage of getting a very better percentile rank. Then what is flexibility? Then when the flexibility is 1, proportionality is achieved. What is meant by sensitivity? What is meant by setting? These formulas are important. Flexibility, proportionality, sensitivity, and setting. These 4 areas are important. When do you say module is the rigid module? When do you say it is the semi-rigid module? Do you say it is the non-rigid module? The three definitions along with examples. Definitions and examples are important. Definition and examples are important for both GATE and ESE examination. In ESE examination, in match the following also, the question is asked. The chapter number 8 is diversion headworks. In diversion headworks, my dear friends, what are the important subtopics you must remember? What is the difference between when do you call the diversion headwork as a weir, when do you call it as a barrage? What are the types of weirs? Gravity weir and non-gravity weir, like that. What are the different components needed to serve various purposes in the diversion headwork, like river training works and canal regulation works? Which component will serve what purpose? What is the duty of the divide wall? How do you fix up the discharge in the under sluices? Q under sluices is important. Then the 5 types of failures. Failure of weirs on permeable foundations is very, very important. Failure of weirs on permeable foundations. Why? Because diversion headworks or weirs are constructed across the river. River beds are sandy. Sandy is having higher permeability. That's why when a weir is constructed, it will be on a permeable foundation. Failure chances will be little bit more. 5 types of failures are likely to occur. We should know how to control them also. Failure due to sloughing action. Failure due to standing wave formation, that is the hydraulic jump on the downstream side. Failure due to rupture of the floor. Failure due to rupture of the floor. Failure due to uplift pressure. Failure due to uplift pressure. Failure due to piping or undermining. Piping or undermining. What are these 5 failures? What are the causes of failures? How to prevent or control these failures is important for us. For uplift pressure, minimum thickness is one important formula. 4 by 3 times H divided by SE minus 1. H is the net uplift pressure head, also called residual seepage head. You can calculate by means of any of the earth pressure theories. One important formula. In order to control the piping by failure, you must increase the creep length to the greatest extent, provide greater depth of the piles, or provide more number of intermediate piles, or adopt both. It is highly essential because piping is the most dangerous failure. And in this context, we got 3 theories. 3 theories are available. One is called Bly's creep theory. I must be less than or equal to 1 by C. C is called Bly's creep coefficient. Total creep length by head of the water, with the creeping length weightages are 1 horizontal to 1 vertical. The crux of the Bly's creep theory. Equal weightages for both horizontal creep and vertical creep. And creep coefficient C is equal to L by H. your hydraulic gradient must be less than or equal to 1 by C. For the given soil, of course, C is constant, I can be controlled. That's why it's always obviously valid condition. Second one is the lanes weighted creep theory. In the lanes weighted creep theory, 1/3 horizontal to 1 vertical, and I value must be less than or equal to 1 by CL. CL is called lane's creep coefficient, L lane divided by H. Because the weightages are different, your creep coefficients are different. They may give a simple numerical on Blaise theory or lane's theory, or the most important as on today valid theory is Kosla's exit gradient theory. Kosla's exit gradient theory. Kosla's exit gradient theory. This particular theory which will be based on Laplace equation. Laplace equation, dou square phi by dou x square plus dou square phi by dou y square is equal to 0. He has defined what is exit gradient. For the safety of the wear against piping, exit gradient must and should be less than IC. IC is called critical hydraulic gradient. IC is 1 minus n into G minus 1. N is the porosity, G is the specific gravity, E is the void ratio. GE formula, exit gradient formula is also important. Sometimes we'll give the dimensions, we'll ask what is the exit gradient. H by D 1 by pi root lambda. H is the head of the water meant for a diversion. D is the depth of the most important downstream pile. Lambda is a parameter which is dependent on alpha. Alpha is nothing but horizontal span divided by downstream vertical pile depth. Anyway, these values are important. Factor of safety against piping is given by IC by GE. It must be more than 1.5. Then only we can declare that the wear is safe against piping. Unless otherwise factor of safety exceeds 1.5, we cannot conclude that the wear is safe. These areas are important. If you are asked what is the most important subtopic, your answer, Kosla's exit gradient theory. Kosla's, either he will give a theory question or he will give a numerical. Most important of the entire is a long chapter. I told you, but it is the fourth preference. First preference, third chapter, water requirement of crops. Second important is design of unlined canals in alluvial soils, chapter number 6. Third preference is 9th chapter, gravity dams. Fourth important chapter is diversion headworks. When you come to the 9th chapter, gravity dams. Most important area, what is the limiting height of the gravity dam? Limiting height of the gravity dam is given by F divided by 2S minus C plus 1. Whether it's a high dam or low dam, how do you decide? If it's a high dam, what is your consideration? If it's a low dam, what is your consideration? What are the three profiles of a gravity dam? That is also important. How do you fix up the freeboard in common profile and practical profile? How do you fix up the freeboard? Most are 99.9 times 3 by 2 times height of the wave. Other two possibilities are 4 by 3 HW plus wind setup and 0.9 meters. Those and 99 or 100% you can say freeboard of the gravity dam in common profile and the practical profile. Elementary profile has got zero freeboard, we know. So freeboard is important. What is reservoir empty condition? Where in what quadrant resultant will be there is also commonly asked. What are the modes of failure? Sliding. To avoid sliding, one is FSS, mu sigma V by sigma H. If mu value is not given, you can take 0.7 to 0.8. If you take shear resistance also into account, SFF, FSS plus BQ by sigma H, this must be more than 2. One is the sliding failure. Second one is the overturning failure. To avoid overturning, factor of safety against overturning is sum of the stabilizing moments by sum of the overturning moments. This must be at least 1 or otherwise minimum 1.5, so very good. Then failure due to compression. Checking for failure due to compression should be taken at the toe. At the toe, normal stress is maximum, it must be less than F. F is the permissible compressive strength of the concrete we use for the construction of the gravity dam. And to check the dam whether it is safe in tension or not, E must be less than or equal to B by 6. That is validity of middle third rule. Validity of middle third rule. Middle third rule. These are important. Formula for principal stress, formula for shear stress are important. Formula for principal stress and shear stress for both common profile and practical profile. In elementary profile, design bed width is one important area, friends. Design bed width will be greater value of H divided by mu into S minus C, H divided by root of S minus C. Minimum this much to avoid sliding, minimum that much to avoid stability, to avoid danger, to avoid overturning. Greater value of these two will make the dam safe against both sliding and overturning. Thus, design bed width of an elementary profile is given by a greater value of these two. Such areas are very, very important. When you take up the spillways, refer to Ogee spillway and siphon spillway. 5 types of energy dissipators, jump height curve and tailwater curve, their relative positions. That is also very important. Spillways is not that much important for gate. I repeat once again, water requirement of crops, design of unlined canals and gravity dams. If still time permits and 1 hour, 2 hours time is available for irrigation subject preparation, go through diversion headworks. These 4 areas are important, especially first 3 very, very important. 99% you can answer the gate questions of irrigation by referring to those 3 chapters. For ESE, there is no excuse, there is no exclusion. A to Z topics, A to Z portion you have to prepare. ESE paper is always exhaustive. Theory, simple definitions, mathematical concepts is application. All possible questions are asked. I wish you good luck for the forthcoming examination. Exam is approaching and any doubts you can contact the admin people, they will send to us. We'll be able to answer to you happily. We as faculty are ready to serve you in every possible aspect. Good luck to one and all. Good luck.